So hello and welcome to Steps to Maths, and today in Steps to Maths we're going to be looking at Venn diagrams, and in particular we're going to be looking at Venn diagrams where we're going to be thinking logically. So in order to think about this, I've labelled the diagram of the universal set, which as you know is the rectangle, and I've got two sets, set A and set B, and I've labelled all the different areas in there. I've labelled this area 1, this area 2, this area 3 and this area 4. Now you already know these symbols, so you'll know that area 1 is A less B. You'll know that area 2 is A intersection B. You'll know that area 3 is B less A, or B set minus A. And you'll know that area 4 is A union B complement. There may be another way to write that, but I'm writing it as A union B complement. Now in this little video, I'm going to tell you that the number of elements in A is the same as the number of elements in B. Now we know that the number of elements in A is the number of elements in here plus the number of elements in here. We know that the number of elements in B is the number of elements in here plus the number of elements in here. The number of elements in B is anything inside the circle A, so we include area 2 and 3. So everything in 2 plus everything in 3 gives you everything in B. Everything in 1 and everything in 2 gives you everything in A. Now we're coming to the logical thinking. And I'm saying if we know that the number of elements in A is the same as the number of elements in B, then we know that the number of elements in area 1 is the same as the number of elements in area 3. Now it's useful when we begin to think in terms of numbers. So imagine this was 6, this was 5, this was going to have to be 6 as well, so that A is the same as B. The number of elements in A is 11. The number of elements in B is also 11. So the number of elements in A is the same as the number of elements in B. So the question is there any way that if we had 11 elements in A and 11 elements in B, that this wouldn't be the same? And there really isn't. Because we know that if the number of elements in B is 11, then the number of elements in here must be 11, take away 5, the intersection. And we know that if the number of elements is 11, then the number of elements in here must be 11, take away 5. And the point about logical thinking with algebra is it doesn't matter how many are in here. These two will always be the same. That brings us on a little bit to equations. So let's have a look. We know that, actually it's going to be a little hard to see unless I show you the picture. We know that the number of elements in area 1 plus the number of elements in area 2 is equal to the number of elements in area 2 plus the number of elements in area 3. So we're told this. This is something we are told. So if number 1 and number 2 equals number 2 and number 3, then we can figure out that the number of elements in area 1 is equal to the number of elements in area 3. So we do this in algebra with equations, and we think of equations as a balance, so that if I remove this from both sides, then my balance is still balanced, so this is still true. But if you think about it in terms of the picture, you'll begin to see that, you'll begin to understand that. But remember, you start with numbers to get an intuition of what's going on. You've got to try and balance things using numbers for a while, and then you'll begin to understand how the numbers are working and how the logic follows. So we're thinking logically. So this is one way of thinking logically. We're going to move on to a second way of thinking logically. So all of this logical thinking is going to apply to some of your questions that you are going to have to do today. Actually, let's go back to this one here. We've got area 1, we've got area 2, we've got area 3. Let's try something different. Imagine I told you that the number of elements in area A is 1 less than the number of elements in area B. So how do I say the number of elements in area A is 1 less than the number of elements in area B? Well, that would mean that whatever the number of elements in area B was, I would take away 1 to find the number of elements in area A. So if I have the number of elements in area B and I take away 1, then I can find the number of elements in area A. So we say that the number of elements in area A equals number of elements in area B, take away 1. So this is something I'm telling you. You're told this. And you're told this in English, you'll be told that the number of elements in area A is 1 less than the number of elements in area B. So I'm going to say, if this is true, what can we figure out logically? The symbol means if this is true, then what can we figure out logically? Or therefore, or that it follows that. Well, what happens then is the number of elements in area 1 is also 1 less than the elements in area 3. And if you look back at what we just did, you can see it works the same way. If I just stick a minus 1, minus 1, minus 1 at the end. So when we're working with equations, it helps to follow logic. What we're doing with equations is a logical sequence that brings us from one piece of information to another piece of information. That's what equations do. That's what all the maths that you do with equations really does. It brings you from one logical statement to figuring out some other logical statement. Okay, so this is the information you're going to need to know in the questions that you have. You'll be told that the number of elements in area A is 1 less than the number of elements in area B. But logically, you'll know that that means the number of elements in here is 1 less than the number of elements in here. And you can figure that out by trying it with different numbers and seeing if there's any other way to do that. That's how that kind of works. And that's how you figure it out. And this is logical thinking. Let's have another little look at a little bit of logic. It won't come up for a while, but we're going to tell you that the number of elements in area A union B, let's think about that. That's 1 plus 2 plus 3. That's 1 plus 2 plus 3. Okay. And we want to figure out how that relates to the number of elements in area A and the number of elements in area B. Well, we know that area A is 1 plus 2. We know that area B is 2 plus 3. Now, unfortunately, I wanted 1 plus 2 plus 3, but I've counted 1 plus 2 plus 2 plus 3. So to get back to this, I'm going to have to subtract a 2 to make this true. What was the area 2? Area 2 is A intersection B. So if I take away the number of elements in A intersection B, then this will be a true statement. Now, sometimes what we do to say something is a true statement or something is always true, we write 3 equal signs. Generally, you probably won't see this. Okay, this just means this is always true. It doesn't matter what in is in 1 or what's in 2 or what's in 3. This is always true because it's an equality. Something that you probably come across in 5th or 6th year maybe. Okay, this is always equal to this. Now, here's a little question for you. When is A union B, sorry, not A union B, when is the number of elements in A union B equal to the number of elements in A plus the number of elements in B? And you can compare this with your equality. The equality is always true. The number of elements in A union B is always equal to the number of elements in A plus the number of elements in B less the number of elements in A intersection B. When is this true? This is sometimes true. And if you compare the two of these, you should be able to see when this is true. This is 0. Okay, so 2 things I want you to remember. If the number of elements in A is less than the number of elements in B, is 1 less than the number of elements in B, then the number of elements in here is 1 less than the number of elements in here. Okay, so that's just something I want you to know. And what else do I want you to know? Okay, yeah, you should be able to do the questions that are on today's exercise with knowing this. And I've given a few little hints, ways to think about things that will help you doing the questions. I've done it subtly, I haven't explained why I'm doing this. But if you look at A union B and you think that's 1 plus 2 plus 3, and you look at A and B and think that's 1 plus 2 plus 2 plus 3, and you go, I've counted 2 twice. I didn't want to count 2 twice. I'm going to have to take away area 2 now. That's something you're going to be thinking while doing these questions. So have a go with those questions. They're a little bit of logical thinking. I've no doubt that you're going to find them easy. The logic is actually a lot easier when you're actually doing the questions than when you're trying to think about the logic. So the questions themselves are much easier. So it's much easier to work with numbers than it is to work with logical expressions. But have a go with the numbers and try to think about some of these ideas while you're doing them. Okay, so best of luck.